The name comes from a mistake. In the early 1700s, whalers pulled open the head of a sperm whale and found a massive cavity filled with a pale, waxy liquid. They did not know what it was. They assumed it was reproductive fluid. They named it Spermaceti, which is Latin for seed of the whale. The name stuck. The assumption was completely wrong. What they had actually found was one of the most chemically useful lubricants ever discovered. And for most of the 20th century, it went straight into your car. Sperm whales carry a specialized organ in their skull called the Spermaceti organ. In large adults, it holds up to 2,000 liters of this waxy fluid. The whale uses it for echolocation and buoyancy control, cycling the wax between liquid and solid states to adjust its depth in the water. To do that reliably across ocean temperature gradients, the wax has to maintain consistent properties across a wide temperature range without breaking down. That requirement, built by millions of years of evolution, is exactly what engine engineers had been chasing since the internal combustion era began. The technical term for what makes spermaceti special is wax ester. Most animal fats and plant oils are built from a molecular backbone called a triglyceride. Triglyceride-based oils have a significant weakness. They thin out dramatically under heat and thicken severely in cold. Their viscosity-temperature relationship is steep and hard to manage. Spermaceti is built differently. It is a long-chain wax ester, primarily cetyl palmitate, and its viscosity temperature curve is nearly flat. Engineers call this a high viscosity index. What it means in practice is that the oil behaves almost identically at negative 30 degrees Fahrenheit as it does at 250 degrees Fahrenheit. That is not a chemical property you can easily manufacture from petroleum. By the early 1900s, sperm whale oil was being refined and blended into industrial lubricants. By the 1940s and the 1950s, it was standard in military applications, including precision instruments, aircraft navigation systems, and guidance components, where consistent viscosity was not optional. By the 1960s, General Motors was incorporating it into automatic transmission fluid. The original Dexron formulation used spermaceti-derived additives specifically to achieve the stable performance profile that transmission clutch packs require across a wide range of operating temperatures. Then the United States banned it. The Marine Mammal Protection Act of 1972 prohibited the import or sale of marine mammal products in the country. Sperm whales had been hunted nearly to extinction. Population estimates at the time had dropped to somewhere between 300,000 and 450,000 animals globally. That was down from an estimated 1.5 million before commercial whaling scaled up in the 1700s. The ban was not controversial from a conservation standpoint, but it created an immediate engineering problem. Automatic transmission fluid had to be reformulated. So did gear oils. So did the United States Army's standard differential lubricant, which had been running a sperm whale-based product designated Gear Oil 6308. The space program had been using spermaceti in several precision applications. Every one of those products needed a synthetic replacement that could replicate the wax ester viscosity profile without using whale tissue. The answer that came closest was jojoba oil. Jojoba is a shrub native to the Sonoran Desert in the southwestern United States and northern Mexico. Unlike most plant oils, jojoba oil is a liquid wax ester rather than a triglyceride. Its molecular structure is similar enough to spermaceti that it was adopted almost immediately as a replacement in cosmetic and industrial applications once the ban took effect. By the late 1970s, jojoba cultivation was being actively developed in Arizona and California, specifically to supply the lubricant market that sperm whale oil had vacated. But jojoba was not a perfect replacement. The chain length and thermal stability of synthetic wax esters developed in the decades since have come closer. But the natural compound that sperm whales spend their entire lives synthesizing inside a dedicated organ in their skull still represents a benchmark. The reason those whales evolved it is the same reason engineers wanted it. The ocean demands a lubricant that works from the surface to a depth of 2,000 meters, across a temperature swing of more than 100 degrees Fahrenheit, without failing under mechanical stress. Your automatic transmission does not ask for much less. The product is gone from shelves. The chemistry it was based on is still the target that synthetic lubricant engineers have been chasing for 50 years. The next time someone tries to sell you on a new synthetic formulation, by claiming it maintains stable viscosity across extreme temperatures, understand that the benchmark they are competing against was perfected inside the skull of a whale, named incorrectly by a sailor who had never seen anything like it before, and banned before anyone fully understood what it would take to replace it.